What we're going to do today is we're going to build a simple job portal API. So we're going to call it PyJobs. The design is here. The link is also in the chat. And it's a very simple API, obviously simplified. A real job portal wouldn't be like this. It would be more complex, but it will help us make the, to explain how FastAPI works. So it has a collection of very simple endpoints. They allow us to post a job listing online. They allow us to update the job, delete it, get the list of jobs. And we have two very simple schemas here for how to create a job and how to get the job. We analyze them in a moment. The first thing we're going to do is to look at the API specification to understand the requirements. So if you work on an API at some point, and this is a serious API, normally you will get the design first, and it's going to look something like this in YAML, listing of the requirements of the API. So we're going to go through this, how we understand and analyze the requirements of the API specification. And then we're going to set up the folder, the project. So we're going to create the folders, the files, the project structure in a way that is structured and you could say predictable. So it's a structure you can follow in other projects as well. We're going to build the API progressively. So if I had to build an API myself from scratch, what I would do is I would follow an approach like this, in which you're building the API in iterative steps. And in every iteration, you can take a step back, look at the API, do some testing, and move on with confidence. So we're going to follow this approach. We're going to have the roots first. We're going to be returning hard-coded payloads at the beginning. Then we're going to add validation models for the return payload, make sure it's looking right. And then we're going to add validation models for the request payloads, make sure people can send a payload to the server. We're not going to have a database. We're going to do that in a workshop next week. So this is the first workshop it's like a series of 3 workshops. The first one is this one. We build the API layer. Then we build the database models. And in the final workshop in the following week, we're going to put authorization in the API. We could do more things. We could have a service layer. We could do testing and so on. I'm going to cover a lot of those things in different workshops next year. So there's a note at the end of the document here for later workshops. And so to stay tuned, you can check my website, MicroAPIs workshop. You can check that, or you can subscribe to the newsletter and you will receive notifications about upcoming workshops, and you will also get discounts for the paid workshops. Again, any questions about that, just let me know. So today we focus on the API layer. We are going to create the Pydantic models for the payloads. We're going to learn to add URL query parameters to the API. URL query parameters, usually we put them on a get list endpoint, and we use them for pagination or filtering typically. Then we're going to learn to handle also URL path parameters. Those are parameters that are part of the URL. So typically in a resource endpoint, so something like job/ID, that's our URL path parameter. And we're going to learn to set the status code of certain responses, because by default, FastAPI returns 200 responses, but some endpoints need to return something else, like the post endpoint should return 201, which means created. We're going to learn to do that also. We're going to be testing all the time the API using FastAPI's self-generated Swagger UI. And finally, we're going to deploy to Heroku. Now, one word about that. You probably know Heroku is dropping the hobby or free dynos by the end of this month. So if you are going to try this tutorial by the end of the month, you would have to pay to do these deployments. What you can do is just pay for, subscribe for a month and then close it. That's unfortunate, because Heroku is really great to try, to get started with deployments and learn how it works. The alternative these days seems to be Render. So what I'm going to do in the coming weeks, I'm going to test deployments with Render and try to get it right for FastAPI. They have tutorials for Django and I believe Flask as well, but not FastAPI last time I checked. So I'm going to try to get it working with FastAPI. And once I have something, I will update this document so that you can have this information here. As I run, this is a workshop, I run multiple editions of it during the year. So in every edition, I will be, improving these documents. So feel free to check it out. You're always going to have access to it and to the latest and best information that I get here. So that's the plan for today. Before continuing, let me know if you have any questions now, and also if you can hear me well.
Yes, I can hear you.
All right, perfect. Thank you. Okay, so let's start with the API specification. So this is the API. I produced to do the design, I've used stoplight. There is section here. So what is OpenAPI? Feel free to read this. So it's just the standard we use to document REST APIs. It uses JSON, a subset of JSON schema to define where the validation rules for payloads and so on. And to produce an OpenAPI design, you can use different tools like Stoplight, Postman's API Builder, or Insomnia. You have the links here. The Stoplight is free to use if you use it just for yourself. You have to pay if you work in a team, I believe. But to get started is really easy to use. So I thought this is what I'm going to use for this tutorial. Again, you can access the link. The link is in the chat. Let me know if you have any issues with it. And what we have here is these 7 endpoints that allow us to get a list of jobs, create a job. We can get a specific job. We can update it. We can delete it. And then we have 2 additional endpoints that allow us to cancel or reactivate the job. The idea here is if we have a job listing, we're having applications and we want to stop applications at some point, we're going to cancel the job. It's not going to be visible. If we want to continue receiving applications later on, we're going to reactivate it. We have 2 schemas here, 2 models. So when we create a job, we're going to send this payload to the server. And then we have the get job payload, which is what we get from the server. So what we mean, question here, what we mean by job here is a job listing. So it's a job portal API. And we're going to allow people to create job listings and to update them, manage them, and to list them. So job means a job listing here. And so when we get the job representation from the API, it's going to look like this. It's very similar to the create job payload, but it's slightly different. So the get job contains server-side or read-only properties like the ID and date listed, which is when we create the record. And it changes the representation of some properties. So in create job, so as a client, you send a payload to the server to create a job listing. You set the location and the header using IDs of those entities. We would have a database, obviously, in the server where we can check these IDs. When we return the job to the user, we are going to use these IDs to change the property for a representation of that entity. So the location is going to have information about the city, the state, and the country, and the header is going to have the recruitment agency's name. And again, we're not going to have a database here, so we're going to hard code a lot of these things in this workshop today. And in next week, we will have some dynamic data in the database, and we will be able to play around with these IDs. We're not going to have a database, so we're going to have an in-memory list of objects. So we're going to start with a hard-coded list of one object, and then we're going to make it dynamic. And what we're going to do is just add and remove elements from the list. And one thing to notice here is the state. Everything is required. All properties are required except the state. So in the location, because not every country has the notion of a state, so this is going to be optional. And we're going to see how we handle this in Pydantic. So in Pydantic and generally programming languages have this notion that an optional property tends to be a nullable property. Not all programming languages, but some of them do. In a database would be the same. We will have a nullable column here. Now that doesn't work for OpenAPI or JSON schema. A nullable property is a property that may not be present in the payload, but if it is present, it has to be the type we specify here, which is a string. Actually, one question: can you see the screen well? Maybe it's too small for you. Let me zoom in, anyways. So the state is a string, and it's not required. So we have the option of not including it, or if we include it, it has to be a string. I know saying states is not that's not valid for OpenAPI. So we're going to see how we do that how we handle that case in Pydantic. So I think that's all for the API specification requirements. Let's get on with the code now. And again, if you have any questions, always feel free to stop me, drop your questions in the chat, and we discuss those questions. So let's go to the terminal. And I created a folder here. So I have a folder called workshops. Within this, I have a folder for FastAPI workshop, which is today's workshop. There's nothing here in the folder, and I only have a FastAPI file because I created an environment. To do this, I'm using ppen. You could use poetry as well. So what you would do here is ppen Python 3.10 in this case, and it's not doing anything because my environment is already created. So, and that's the pip file. It's empty at the moment. So what we're going to do first is we're going to install the dependencies. So we're going to install pipenv, install FastAPI, and UVCon. So FastAPI is the API framework we're going to use to build the API, and UVCon is going to be our worker process manager. So when we run the API in a server, there is a chance that our server crashes, FastAPI crashes because of a memory leak or because of something goes wrong in our code and it crashes. So what UVCon does, it manages those crashes. They make sure that it's managing a pool of processes. So if one of those processes crashes, it doesn't matter. UVCon is keeping everything up and running. If UVCon crashes, obviously, too bad. Then we need to restart the whole application. So dependencies installed. We now activate the environment with the pipenv shell. And now we are going to set up the folder structure. Now, the type of structure I want to follow here is something that would be compatible with a hexagonal architecture. So hexagonal architecture, if you're not familiar with the concept, is a architectural pattern in which we isolate the business layer from everything else. The idea is that the business layer doesn't depend on anything, so that this is so that we can continue extending and evolving the business layer without interference from external dependencies of our app. An external dependency is the database. So if we change the database, we shouldn't have to change the business layer because the functionality of the app isn't really changing. It's just an implementation detail. Hexagonal architecture, I'm going to write it here. Hexagonal architecture. It's also known as architecture of ports and adapters. And there is the article that kicked off this pattern is, let me see if I can find it. So hexagonal architecture. So you can read about it in Wikipedia. But this article, so from Alistair Cockburn, this is when the architecture is first proposed in early 2000s, I believe. So this is the article. And so this idea fits into a long tradition of figuring out how we can build applications with isolated layers so that we can evolve each layer independently of each other without, we change one, enforcing tight coupling and making sure we can evolve each layer separately according to its own necessities. So previously we had onion architecture. We also have this idea of multi-tier architecture. So hexagonal architecture just fits within this tradition. And the idea of the hexagon is not because it looks like a hexagon, it's just to reinforce the idea visually that there is a core layer of the application in the center, and the edges are the adapters. So database is an adapter that allows us to access data from a persistent storage. An API is an adapter that allows us to expose the service through the internet. If we had a CLI, that would be another adapter that allows us to expose our business layer through a terminal. We could expose this the service also through a traditional web application, like with content dynamically rendered in the backend. You would typically do that with Django, for example. So to do that, there are many ways of putting a hexagonal architecture in place, but I think folder structure, the project structure matters. It goes a long way to helping you ensure that each layer is decoupled. So what we do here is we're going to create, first of all, a folder called PyJobs. That implements our PyJobs service. Now within PyJobs, this is the root folder for everything we're going to implement. Within PyJobs, we create a folder called web. And within web, because we can have different types of web interfaces. Like I said, we could have something like a Django application, and we can have an API. We can have a REST API. We can have a GraphQL API. So we're gonna create another folder called API here. So it's with a P. And if we had a service layer, that would be within PyJobs. We would say PyJobs. We could say jobs or jobs service, for example. So we would do something like that. If we have our database or our data access layer, we would say maybe make their PyJobs models, for example. So we could do something like that. And then when we list everything here, like this. So what we have is the root of our whole service, and then we have the service implementation within its own scope. We have the models in their own scope, and we have the API within its own scope. Each layer should be implementing what goes into the layer. So we shouldn't have business layer within the web API or within the models, and we shouldn't have database logic within the job service or the web API. In this workshop, we're gonna break a little bit these rules because we want to keep it just very simple. Only going to have the web API, so everything is going to be implemented here. But next week, we're going to move database logic to the models. And next year, when we have a workshop about service implementation patterns, we will move the service implementation into the service. And another thing here is we want to apply the dependency inversion principle. So we want to make sure these implementation details, the models and the API depend on the service, because the service is the core business layer of our app. We don't want that to depend on databases or the type of API we are using. We want our APIs, API interfaces, or our databases to depend on that. So that should be the direction of the dependency. So now let's create the files. So we're going to create a file within PyJobs. Within web, it's going to be our, let's say, server file. We're going to create another file. We're going to create two files. So within web and API, we're going to have API and schemas. So the API file is going to implement the API roots of the API, and schemas is going to implement the Pydantic validation models. Right, that is for project structure. Okay, any questions so far? Okay. Again, any questions, please always feel free to drop a question in the chat or activate your mic and ask me. So first thing we're going to do now is we're going to create an instance of the FastAPI server. And so that's going to be our server, and that's what Ubicon is going to use to run our server in different processes. So we're going to say server equals FastAPI. We import that, and we're going to say debug is true. One thing about the editor, I'm using PyCharm, but if I'm not mistaken, you would have the same features in VS Code or even more. So you don't have to use PyCharm to do this. So that's the instance of the FastAPI server, and now we are going to implement our roots in the API file here. And we're gonna implement them using this concept of a router in FastAPI, which actually comes from Starlet. So we're going to say router is, I would say IPA router, I believe. Yeah, so from FastAPI. And then to implement the every endpoint, we use decorators on the router. There is something like router get, and that's going to be a get endpoint on a specific path that we put here. It's going to be job. Let's check the API specification. So jobs, exactly. One thing also I want to say, a very useful tool to visualize API specifications is Swagger Editor. So if you paste an API specification here, you get the visualization here with Swagger, and it also validates the specification. So if I change something here, if I say the type is ASDF, it tells me here that something is wrong. And here's the error. So you can jump onto the line, you can replace it by a number, and now it's correct. So that's really useful. Now, coming back here, we're going to build the roots first. So we're going to say this is the get jobs endpoint. So we're going to say this is list jobs. And for now, we're just going to put a pass. We're not going to implement it yet because this is sufficient for FastAPI to get the information about the endpoints and render some documentation already. And that's going to help us to see whether the implementation is going well or not. Then we're going to say router host jobs. And this is create job has, and then router. And now we're going to have the resource endpoints. So which are these ones with the specific ID. So get, put, and delete. So we say get job ID. And we say get job. And this is pass also. Another thing I want to say is because I'm coding live here, very possible I make mistakes. So if you spot any error or something, also let me know. It usually happens. Now put, and here we say should be jobs actually. So jobs and job ID, and we say update job and pass. One word about the put endpoint. So we are doing updates here with put. If you check the document, there is a refresher about HTTP methods. So we can do updates with a put or a patch. They're different in semantics. So the semantics of a put endpoint is you replace the representation of the entity in the server, which means we are, the client is forced to send a full representation of the object. In a patch endpoint, we can be more selective. We can update the specific properties of the object. Another thing about the semantics is, so a lot of people always bring up the question that put is supposed to be idempotent. So you can use it to update an object or to create the object if it doesn't exist in the server. Now that's semantics. Those semantics are actually qualified by the fact that if you have the semantics is something along the lines of an API or a server that has an endpoint that creates entities, is something along those lines, would have to put endpoint only for updates. I'll put the link here actually so that you can read that. So in this case, we're using put for updates only. So that's the endpoint here. And then we have router delete, and we say jobs, job ID. We say delete job, and that's a pass. And then we're going to have the two actions, the activate and was cancel and deactivate. So those are here. So cancel and activate and reactivate. So router post jobs job ID. Oops, that is cancel. And then this is cancel job. And then we have router post jobs job ID, and this is reactivate, and this is reactivate job and pass. That's how we define our routes in FastAPI. If we were using Flask or Django, we would be able to use class-based routes. So that works something like this. We say jobs endpoint, and then we say get. So we say get, and then we say pass, and then we say post, and then pass, and we will have the same for. Oh, so this represents a URL. So we will have maybe something like URL jobs or something similar. We can't do that in FastAPI, although I believe it's possible in Storelet, which is the framework on top of which is FastAPI is built. So maybe this is something that comes later, a feature that comes later in FastAPI. For now, we have to do with functions, which is not too bad. But just so you know the frameworks, we have that possibility of using class-based views. So with this, we can already do something. The endpoints are not doing anything, but we can already visualize that. So if we say ubicon pyjobs, so to run this server, we need to give the path to the variable we created here, the server variable. So that's going to be pyjobs.web.server : server. That's the syntax we use to describe the path to the object. So we say ubicon pyjobs, we say web server. And if we put the reload flag here, the server will be reloaded every time we change a file, so we don't have to restart it ourselves. So that is, I believe it's running already now. And we can visit the server here. In the docs endpoint is going to give you the documentation, the Swagger UI. Now there are no spec because we haven't registered the router yet with the server object here. So what we do is we say server include router, and we're going to import it like this. We're going to say from pyjobs web API import router as jobs router. So if we If we have other routes and we want to import them all of them here, then we can name each of them separate differently. So we would do that. Question here. So what was the command? So the command is ubicon, like this. So ubicon, that's the worker process manager. So it's by default it's gonna be expecting a path towards an object that represents a server, and probably it's gonna expect an ASCII server. The idea is so we have I think WCI and ASCII. So where the document is here. So I explain an ASCII server here is an asynchronous server gateway interface. Basically, it just means it's an asynchronous server implementation. So Starlet is like that. FastAPI on top of a Starlet, then it's asynchronous also, and ubicon leverages that synchronous nature of the framework. Flask, I think Flask recently, since I think version 2 is also asynchronous, and Django maybe also has asynchronous functionality as well. So it's not anymore a specific feature of FastAPI. But anyways, that's what it is. So we say ubicon, and then the path to the server application object. So that's pyjobs web server. The colon is when so everything is a file, colon the variable within the file, and then reload. So that's the server running now, and we can reload this, and here's the endpoints. So what does async mean with respect to FastAPI? So all it means is that we can, so two things actually. One thing is we can implement the it's a direct message. So it's a question: what does async mean in the context of FastAPI? So it means two things. It means that we can implement async routes. So our routes here are asynchronous, but if we have to, we can say async def create job. It also means that by default, FastAPI is processing our the requests to the server, is processing them asynchronously. So if we have if we have a function that is IO bound, so it's waiting for a query from the database and it's just sitting idle, FastAPI can switch to another request and process it while the other job is waiting. And what it also means is we can have async routes here, and that helps us if we're using an asynchronous dependency here. So imagine, for example, async PG. So I have some list here. So there is async PG, async. So a lot of libraries are supporting async programming now in Python, right? So we have async PG for Postgres. SQL Alchemy is in the process of supporting asynchronous programming as well. So SQL Alchemy 1.4 is going to have support for asynchronous programming. In SQL Alchemy version 2 is going to be asynchronous by default from the ground up. So that means we can leverage these libraries by being able to call awake within our routes here directly, which we wouldn't be able to do if the server is not asynchronous. So that's the advantage of having a support for asynchronous programming in our server. So the routes are here now. They don't do anything. So if we want to play around with them, nothing is going to happen because they don't do anything. They return null. But now what we can do is we can create a hard-coded job that looks like a job here, and we can return it from the functions and we can already start playing with them. So we can say jobs. It's going to be an in-memory list again because we don't have database. We're going to put it next week, and here we're going to create the job. What we're going to do to make it easy for us, we're going to come here to stop lights, and we're going to create this example. We're going to copy this example from the get job. We're going to copy this. We're going to put it here. So we don't have to do this ourselves. So we're just going to change a little. So we're going to say Python dev. That's the job title. The rate, we're going to say 1,000 per day, and it's going to be I don't know, US dollars. I don't know how you represent currencies. Again, we would have a database for this. It would be the database would tell us maybe something like this. Not sure. Well, US dollars, let's say. Benefits, we're gonna say, I don't know, work from home. It shouldn't be really a benefit these days, but I can't think of much now. Location, let's say it's gonna be in London. We're not gonna have a state because in the UK we don't have states, so it's gonna be none. That's how it would come from the database. We're gonna change this in Pydantic later so that we drop this property because it's not set to anything. The country is UK. The header, we're going to say it's PyJobs. The contract type is going to be a contract. The other option is permanent. The description is being Python dev. And the skills, let's say it's Python. And also, we're going to say FastAPI. And let's move this correctly. It's going to be live, well, let's say until 2022, 24th of, let's say, November. And date listed is today. So that we're going to do, should be a UTC timestamp here. So we're going to say date time. So we could use UTC now, but that's not the recommended way in the Python documentation to have UTC timestamps. There is a different way they recommend. So let's check it out. So date time UTC Python. So they say UTC now. Right. So here they say don't use it because UTC now doesn't produce a time zone. So what they recommend to do is instead this, the time zone, date time now with a time zone set to UTC. So that's what we do here. And we need to have ISO format representation. So we call that method. The ISO format that comes from FastAPI. So if you work with, from OpenAPI. So if you work with OpenAPI, you have a lot of standards already built into the protocol. So dates are you would check it out. You would check it out in JSON schema. So what it looks at date time. So we check here. So date time is it looks like this. It's following the ISO format. And that's something I recommend you to do, actually leverage those standard formats, because otherwise sometimes there's a lot of confusion about how to format dates or how to format certain things in an API. So don't go for that. Don't get lost in those discussions and just use standards as much as you can. So now we have a default, a hard-coded job here. Let's return it from each endpoint. So what we're going to do here is we're going to say jobs equals jobs. The create job is going to return job, the first element from the list. Get job is going to return also jobs, the first element. And let's actually copy this. This is jobs. So here we see that and jobs and jobs and jobs. Okay, so we are returning a hard-coded job from each endpoint. Now we can go back to the UI here. We can call it and we get the job. Now again, the state shouldn't be null here. If we do it like this, it's going to be invalid. We're going to see how we handle that in Pydantic later. Now let's have now some validation to make sure that the payloads are correctly formed when we return them. So we're going to get the schema from the API specification here. So this is schema. We're going to put it into Pydantic. So let's go ahead and do that. So to create schemas with Pydantic, we create classes. So we say get job model, and this inherits from Pydantic's base model. No, not like that, like this. So base model is the Pydantic base class that gives us all this validation functionality and the ability to transform our objects into JSON schema representations as well. So here we declare our properties as the attributes of the schema as properties of the class, and we set the type using type hints. So we say title is a string. Then rate is an object that has amount per time in currency properties. So let's create that object separately. We say rate model from inherits from base model also. And it has amount, which is an integer. It has amount per time, which is an enumeration actually. So this property can only take on these values hour, day, month, and year. So let's create an enumeration for that. So class amount per time enum. And this inherits from the enumeration class in Python. And we give it the values that are permitted. So hour equals hour. Then we have day, which is day here. Then month is month. And then year is year. And then amount per time here, the type is going to be this enumeration. So amount per time enum. And by setting it to an enumeration, Pydantic, first of all, can check that if we want, we can enforce the type here by saying it's a string. Second of all, it will check that if the value is only one of these values restricted in the enumeration here. So that's all we need to do. So it has amount per time, then it has benefits, which is a string. By the way, another side note here, if you want to make sure it's a strictly string and not something that can be casted into string, you can go this way. You can say strict string. And we can import this from Pydantic. I'm going to leave it as a string for now. I'm going to cover advanced Pydantic validation patterns in the next workshop. So for now, this is good enough. And then we have the benefits, and then we have location, which is an object also. So we're going to create this object as well here. So we say location model, inherits from base model, and we have city, state, and country. Again, everything is a string, but the state is optional. So we say city is a string, state is a string, is optional string, and the country is a string also. Now, I'm using Python 3.10. So from 3.10, we can say something is optional like this, or we can say it's nullable. So we can use the syntax, and this is the preferred syntax from Python 3.10 to declare not optional, but nullable attributes. So there is no concept of optionality really. It's the concept of being nullable. So that's how we would do it. I'm going to leave it as optional in this case, actually, because I think it conveys better the idea of OpenAPI that if the value is optional and not nullable. So this is going to be set to location model. Another thing also, the Python documentation, when doing enumerations, it recommends you put values here using caps instead of lowercase. I'm leaving it as lowercase because it matches the actual value of the enumeration. The reason why they recommend to use caps is so that we can, when you access the value, you would say hour, and then you remember, oh, this is actually an enumeration, so I need to call the value property to get the actual value. So that's the reason. So we have the rate, location, and then we have header, which is a string, and contract type, which is another enumeration. So header is a string, and then we have contract type, which is an enumeration that can be contract or permanent. So let's do that. Contract type enum. Like this. And then we're just going to inherit from enum. And we're going to say contract is contract and permanent is permanent. Permanent. Okay. Right. So the contract type property here is set to the contract type enumeration. So only can take those two values. And then we have description is a string. And then we have skills, which is a list of integers. It's an array of integers. Yeah. So, and again, we are using Python 3.10, so we can do this list integer, as opposed to before we had to do list integer like this. So we can just do it simply like this. So skills, and then we have live until, which is a date time. And that is date time. And we have ID, which is a UUID, and date listed, which is another date time. So we have ID, UUID, and date listed is another date time. Okay, so at the moment, we're not yet handling the special case of the nullable property, well, the optional property of a state. So if we put this Pydantic in the root, our model is going to be valid for now. One comment here, can this be used to generate Pydantic model? Yes, and it can be, and actually maybe it's using data model code generator, yeah, which is it's a good library actually to generate your Pydantic models. So, and that's what I would recommend actually. So I'm doing it by hand just so that you understand how Pydantic works. But my recommendation is actually you use something like data model. You would need to tune the models probably a little bit, but that's fine. You can save a lot of work, especially if you have complex payloads defined in the API specification. You can save a lot of time by using JSON to Pydantic or the data model code generator. But okay, so we have our model here now. Let's see how we hook the model in the root to validate our responses. So we come here to the API. By the way, delete shouldn't return anything. It's a delete endpoint. So it's deleting the entity from the server. There is nothing to return. So that's going to be a tool for response. We're going to see how we set the status code in a moment. So what we do here is we say response model. And that's going to be get job model. Now, if you see, there is also a response class. This is what we're going to use in the delete method to make sure we are not returning anything at all. We will see in a moment. So response model. That is get jobs model. Actually, this is not the right model for the jobs list. The jobs list is a list of jobs. So what we do here, we're going to create another entity. Actually, this is wrong. I was putting in the wrong place. So this is here. All right. Amount per time. I think that's correct. And the currency here missing. So currency is a string. And it could be an enumeration, actually, if we have an enumeration of the values for a currency. And then, so we need another entity here for the list. So we're going to say list jobs model. And this is also from base model. And it says jobs is a list of get job model. So this is the model we need to use to validate the list here. We import it. And all the other are going to use the same model here. Update also, another comment. Is there a difference between snake case and camel case notation? So when it comes here in Pydantic, maybe you're referring to this question, to this here. In this case, yes. So what I'm doing here is I'm copying directly the shape of the property here, because Pydantic is going to validate it exactly as what it looks like here. Now, the difference is when we're working with OpenAPI, usually the notation we use is this kind of notation, which is more common in JavaScript or other languages. But that's a choice of design, actually. So we could have said contract underscore type, and then what we need to make sure is that the shape of the property here matches the shape of the property in the API specification. There is some functionality in Pydantic to handle snake case to camel case and the other way around. But personally, I think it makes things a little bit more complicated. So I would just, this has to be an exact representation of the API. So I would just leave it exactly as what it looks like in the API. That doesn't prevent you from using Pydantic in other places of your app actually to validate payloads. And I actually encourage developers to do that. To validate what comes out of the database, what goes into the database and everything, because it can save you a lot of pain and time debugging and tracing errors within your app when something is not looking right. So that's about Pydantic. Let's continue putting this here. Delete job again is going to use a different approach here. Everything else is going to return the get job model. So let's test the API now. So we come here and we say this, and we get the list of jobs, the hard-coded job we had before. Again, state is null, which shouldn't be like that, but we're going to change it in a moment. And so we can test other endpoints as well. So if we test the post, we get the same payload. The only odd case here is delete, which at the moment is giving us a null response, or another possible value here is a string. We need to change that so that it doesn't return anything at all. We're going to do that a little bit later. So just want to make sure we have everything right. Okay, so I think everything is looking right. What we do now, we want to be able to send payloads to the server to create jobs and to make the list dynamic. So let's do that. So we come here to the schemas and we're going to create another model, which is create job model, and that from base model again. And like I said before, it looks very similar to get job model. So let's paste this here for now and work on the differences. So first of all, get job doesn't have the read-only properties ID and date listed, so we'll remove them. The specification again is here. So I recommend you look at this as we code. So it doesn't have ID or date listed. And then it changes the header and the location properties. They are represented as UUID here. So let's do that. Location is a UUID and header is a UUID. Again, the idea is we're sending this payload to the server. The server is going to check the IDs in the database and replace them with the actual details of the agency or the location. In our case now, it's going to be hard-coded, but next week we will be able to play around with it. So this is really what we need to do the create job model. So let's go to the API now. And how do we intercept a payload is like this. So we say create job payload, and we set it to the Pydantic model, the type. So input. Well, I'm calling it payload. It could be job. It could be job details. The name here is irrelevant. It's just a parameter in your signature, in the function signature. So I'm going to call it payload because I'm going to use the variable job later for other thing. And we need this input in the update, and that's all. And now let's do the list dynamics. So we're going to capture the job details by doing payload and calling the dictionary method. This is obviously not what we would do in a real application. In a real application, we would be saving to a database. So we would be accessing attributes directly from the payload, which is the good thing of having type notation here. So we could say, when we're saving, we say job equals job payload skill. So title, for example, we say title equals job title. So we're going to do that when we're going to leverage this functionality when we work with SQL Alchemy next week. So for now, it's just a simple dictionary. Again, not what we would do as a best practice, but just to be able to store the entity in memory. We're going to set the server properties. So the ID is stringified UUID 4. And the date listed, which we set in the server, is the creation time. So that is date time now, time zone, UTC, and ISO format. And what else? And we're going to change the this representation of the agency. So the header is going to be PyJobs. So the user is sending us an ID. What we will do, we will check this in the database and replace it by the right name. But here we just hard coding because we don't have a database. And the location is we say is a dictionary, which is city. We're going to set it to London by default. And the country is UK. And to make it more similar to what we would have in a database, will be a nullable column, state is none. All right. And then what we do is we say jobs append job. And now we can return the actual job. And right. So let's test that this is working. Let's check the API again. So we come here, we reload it. Now it's reloaded. We check the post endpoint. Now we have a payload here. So we have an example. We can send this to the server and we can make sure that it appears in the list. So we say this is going to be, let's say, Java dev. We send it to the server. We got a good response. The Java dev we created, 200 response now. We're going to change it also in a moment to 201. If we come here to the list, we hit the endpoint, and Java dev is here together with the Python dev, which is hard-coded. So that's working. Again, we are going iteratively in gradual steps. We add small pieces of functionality, we test it, and we go back to the implementation. One thing you could say is maybe you should be doing test-driven development, right? And we write the test first, and then we extend the API. Actually, for APIs, what I would recommend instead is use something like a schemathesis. So I'll write the name here. Schemathesis. I'm gonna copy also the link to the repo. Here it is. Okay, so this is the repo, and I'm gonna cover this also in the advanced workshop. Yeah, sorry, I was doing a direct message. Let me put to everyone in the meeting. Okay, this is the schemathesis repo. So what a schemathesis does is it looks at the API specification, and automatically it generates a test per endpoint. And for an API like the one we are doing here, it can generate maybe over 1,000 tests actually. And it checks everything. It checks that the payloads are being, it accepts the right payload. So if your API by chance is accepting a wrong payload, that is going to tell you schemathesis that is wrong. It's going to check also that the payloads returned from the API are correct. The URL query parameters, the status codes, everything is going to be checked. And you don't need to write a single test. That's the good thing of it. So schemathesis uses an approach to testing called property-based testing. What you do in property-based testing is you define the conditions that you define a number of constraints to generate test cases, and then a framework like hypothesis, which is a good property-based testing framework for Python. So hypothesis, you give it some conditions, it creates test cases from those conditions, and then you define based on the properties of the test case, you say whether the test should pass or not. So it's an approach to testing in which you're looking at the properties of the test case as opposed to specific test cases. It doesn't work for everything, obviously, but something like JSON schema, in which we are working with the rules of a schema. So we say, according to the rules of the schema, if the payload abides with it, the endpoint should pass, otherwise it should fail. So that's how schemathesis is working. And that's the approach I would use for the API interface. Now, when you're working on testing specific functionality of your business layer or through the API, that in that case, I would use test cases. But otherwise, I recommend you use schemathesis or something similar. But schemathesis is really the best. So we've proven that we can get data from the API. Where is the here? We can get data. We can create data in the API. Now, to access a specific job by ID, we need to capture the job parameter in the root. So we're going to see how we do that. So you see here in the root, we are calling the parameter job ID. So that's what we do here. We say job ID, UUID. And so that's the type of the job ID parameter. And so what FastAPI is going to do is it checks, it knows here, so based on our syntax here, it knows, oh, there's a URL parameter here. If we are declaring the parameter here with the same name, it's going to match it, and it's going to apply the validation type we apply here, and we can access the parameter in our function body just as the name we're giving it, which is the name of the parameter. So to get the job, we're going to say for job in jobs, if job ID equals job ID, then return the job like that. Now, if we don't find the job, we need to return a 404 response, which means it wasn't found on the server. And to do that, we raise an exception here. So we say HTTP exception, and from FastAPI, and we say status code 404 and detail, which is the message that is going to go in the payload. We say job with ID, job ID not found. I believe it's also possible to have generic error handlers like you do in Flask. You could have the generic case in your API. You can have a generic exception, right? You could say class job not found error exception, and you can raise this exception instead of, in every case, building an exception response. So instead of doing that in every endpoint, you can just raise this error, and you can have an error handler to automatically build this response whenever this error happens. Another message here. So 10 jobs in line 63 Pydantic 63. So what we're doing, because we have a list, what we're going to do is iterate the list of jobs to see if any of them has a matching ID with this ID. We're expecting all the jobs to have the ID property, so we wouldn't use get here. It would be really bad if our system is not assigning IDs to the jobs. So what we're doing is just iterating from the list we already have in memory here. We have a hard-coded job here. We're going to be adding jobs using the post endpoint, and we're going to check them by ID using this approach. If it was a database, obviously, next week, what we're going to do is we're going to query the database by ID using SQL Alchemy. Does that answer the question? All right, thank you. Okay, so this is for the get endpoint. We're going to follow a similar approach in the put endpoint here, and in delete. In delete, we're going to do something else. Actually, we're going to delete it. So we need to copy the parameter as well, the URL parameter. So we're going to put it here before the payload. So I believe FastAPI is going to look first for URL and query parameters, and then it's going to check the payload at the end. So I believe order matters. And then the delete endpoint, we're going to have it also here and here, and we're going to have also the same logic for now. All right. One thing, actually, we're going to set an additional property here. This is our database representation. So we're going to add the visibility. So you're going to say active true. Oh, so the jobs are active by default. What reformat? Okay, good. Now the indentation is now correct. Okay, so all good for the get endpoint. Now let's do the update. So again, let's test here. So this is one of the IDs for the. Well, actually, we need to send so the server is restarted every time we make a change, and because we have an in-memory list, we're gonna lose data every time we restart the server. So let's create another job here for Java Dev. Let's grab the ID, and to make sure this is working right, we test. Oh, we need to reload actually the UI, because we added the URL parameter now. So now it's represented in the URL. We execute, and it's not found. So something is not right. So, well, let me check that it's correctly copied actually. So if we try this, that is correct. So let's copy this ID and let's put it here. And it's not found. I'm sure it's something to do with the type, unless I'm doing something wrong here, which doesn't seem to be the case. So let me put a breakpoint, and we are going to check the types of the data. So if we execute, it's now stopping the breakpoint. So the job ID, which is the URL parameter, is a UID object. Okay, so let's continue. Now it's certainly not found. So what we do here actually is we're going to say UID. Well, let's keep it like that. Actually, what we're going to do is we're just going to stringify the parameter here in the comparison. So we make sure everything we store is as a string, and we need to change just we need to make sure it's a string here when we make the comparison. So we do that. We do that. The breakpoint is gone. Okay, so now we should be able to create another job here. Try. Okay, let's say Java Dev. We send it. We got the ID, and now we should be able to find the ID in this endpoint. So if we do this, okay, so that's not working. I had to fix a bug here. Was that clear? Do you have any questions on what went wrong? Okay, I guess silence means it's clear. But again, if you have any questions, or also if you guys have any, if I'm talking too fast or something, because sometimes I tend to speak too fast, let me know, and so that you can follow up well with explanation. So let's do the update now. So what we would do if it was a database, we would use SQL Alchemy to pass the properties. We could do a little bit nicely actually with keyword arguments. But here we are going to update the job property by property. So we're going to say update like this. And we're going to update only the properties that we are allowing the user to change. So those are the title, the rate, the benefits. They can change the location, but we are hard coding the location in this workshop, so we're not going to worry about that. The header, the same, the contract type, description, skills, and live until. So I'm going to copy this, and in the put endpoint, I'm going to put it like this. We're not going to worry about location because it's hard coded. The same for the header and the amount. And now everything here, we're going to fetch it from the payload. So we're going to say payload title. And the rate is actually payload rates. And why not? Payload. Header, there should be a rate. Why is not? So when we create the job, there is no rate here. Where is the rate? Location, benefits, contract type. Okay, did I delete that? Maybe. Okay, let's see, where does it go in the list? So that should be location, header, contract type. The rate is just below the title. Okay, so here, the rate is rate model. And here also, rate is rate model. Okay, so that should be now correct. That's the rate. The benefits is the payload benefits. The contract type is payload contract type. And description is payload description. The skills is payload skills. And live until is going to be payload live until. Now, one thing I want to check here is to make sure the payload is looking correct. So let me put a breakpoint, and we're going to check that the job has been correctly updated. So let's create a job here. Again, the Java dev, we're going to create it again. We're going to grab the ID. And now we're going to use the put endpoint to change it to, right, actually, so the UI wasn't, so the UI, because I didn't have the rate, the UI doesn't have the concept of rate. So let's change it. And now the rate is here. So what we're going to say is we're going to change the title to Erlang Dev. We're going to send this to the server. We have a breakpoint, but it didn't happen in the breakpoint. That was in the put. But didn't find a job much actually. Okay, let's see if we create the list. If we list the jobs. All right, I guess I did a change. So okay, let's just change the Python dev then. We're gonna change it. We try it out. We're gonna change the Python dev to Erlang dev. We do this, and now it's stopped here. And we just want to check that the job has been correctly updated. So that's good. Now the rate actually should be the thing here is it's an object. It's a Pydantic object. So we want to call the dictionary, but the dictionary also gives us a enumeration here. So what we're going to do is we are going to explicitly access every property from the payload to make it easier. So the rate is going to be amount is payload rate amount. Amount per time is going to be payload amount, no, rate amount per time. And what was also currency is going to be payload rate currency. And also, I guess the contract type maybe it's also formatted State, country, page. All right, contract type is an enumeration, so we want to get the actual value. So benefits contract type is value. Okay, so we have that, and so we can remove this now. And one thing actually I realized we should change here is there should be a date time. Actually, let's modify this. Let's say this is going to be so date time now time zone UTC plus time delta, and let's say days 24, for example. So we get the time delta from, what is this? From date time, yeah. And this is in ISO format. ISO format. All right. Well, actually, I think it doesn't even matter, probably. Let's see if we put it like this. Yeah, I think we will get the right representation anyways. So if we test the list endpoint here, yeah, it still works. So the date still works the same. So we're going to use date objects so that we can compare dates later when we are filtering jobs. All right, so we can create jobs, we can update them, we can list them. All of that is working fine. Do you have any questions so far? Something that isn't clear, something you would like to know if it can be done differently or something? Okay, well, silence is good. Okay, so now let's set the status code of the create job here. So it shouldn't be at 200, it should be 201 according to the specification. So the create job gives you, where is the response is 201. So we do that by setting the status code here, and we say HTTP, if I can get it right, no, status, and that is a module from Starlet, and then created 2.1. So that's how we change the status code of the endpoint. Now delete has 204, so we're going to say status code is status, no content, like that. And then and we need to change the response model. So by default, FastAPI uses a JSON response model, response class. It means anything you return from the root is going to be JSONified, which means if you don't return anything, it's going to appear as a null or as an empty string or something similar. But 204 literally means no content. There shouldn't be any payload at all. So to do that, we change the response class, oops, not the model, but the class to the simple response class from Starlet, like that. So by using that, it's not going to be JSONified. So here we just do a pass. And what we need to do is we're going to say for index job in enumerate jobs. If the job is that, then we say jobs pop index. And this is just a simple way of being able to delete the job from the list. If it was the database, obviously we would have to delete methods. We would commit the transaction and we are good to go. Actually, let's return here. Okay, so that's the delete endpoint. We return a 204 and we use the generic response class to make sure it's not JSONified. We delete the element from the list and we return. And let's implement these endpoints now also. So we say if the job is that, because it's canceled, we are going to hide visibility. So we created an additional property here, which is active. So we're going to say job active is false. And in reactivate, we're going to say the opposite is going to be true. We don't need to worry too much about those endpoints. It's more, once we have a few jobs in the list is when we want to be able to play around with visibility and so on. So that is the most basic stuff in the API. We need to handle the URL query parameters and handle the non-special case of the state. We're going to do that now. Now, question here: why did we change the response class? If we can go over that one more time, sure. So by default, the response class is the response that FastAPI is going to use to format the response object. So by default, FastAPI uses a class, I think it's JSON response. So let me see if we can find it. So yeah, so from starlet, we have JSON response here. So that's the, and what that class is doing is whatever we return from the payload here is going to JSONify that. So it's going to dump it as a JSON. So if it is none, it's going to appear as a null value in the response, which we could see if we can find this here. So I don't know if we use the delete endpoint, but here, so what's happening is, because it's using the JSON response class, it thinks the return value is a string or a null. But that's not acceptable for a 204 response, because 204 means there shouldn't be any payload whatsoever in the response. So to do that, we have to make sure that we can do an empty return here, and that value isn't converted to anything else. So for that, we use the basic response type of a starlet, and that's not going to JSONify the response or anything. If there is no value, it just doesn't return anything. It's only going to do if we return an actual object or something, then this is JSONified. It's stringified, and it appears as a JSON. So that's the reason. If we don't do this, what we're going to have is a null or an empty string or something, and that's going to make our tests fail. With I think schemathesis will verify that we are getting empty responses, otherwise it's going to fail the test. So that's the reason. Does that explain the question? So 202 means successfully, I believe it means successfully processed. Let me double check. 202 status code. So it means it's been successfully processed, but the processing hasn't been completed yet. So that you would do 202, for example, when you're going to trigger a job in a server, and the job is going to take longer than it's going to be processed, and by the time you respond, it's not going to be done yet. So you say, okay, I got it. Process is triggered, but we haven't finished yet, and that's a 202. But 204 is what we usually use for deletes. We use a 204 normally, because when you delete something from the server, you want to say it's been successfully processed, but we don't have anything to return because the entity has been deleted. So it's an empty response. Everything in the 200 group means that it's a successful response. So there's a brief explanation here. So the 200 response, everything is successful, but the semantics are different depending on the specific status code. So 204, we normally use it for deletes because doesn't return anything, means successfully deleted, but nothing to return because it's been deleted. So that's the idea. All right, we can delete now from the list. We can cancel and everything. Let's do a test to make sure it's actually working. So we would say, let's create some jobs here, and we're not even going to change the payload, just create some jobs. So if we check the list now, we should have a bunch of jobs here. And what we want to do now, maybe we want to delete the Python dev. Is the only one we can check. So let's make sure we get the ID of this one here, because all the other jobs look the same. I haven't changed the payload. So we go to the delete endpoint. We're going to test it out. So we do this, we execute, and right, okay, 204. It was successfully deleted, no response, no string, no null, nothing. It's absolutely correct. And if we check the list now, the job shouldn't be in the list if we are doing things correctly. So and it's not. So it should be the first item on the list, the Python dev. So it's not there, so it's working correctly. So, okay, final thing we need to do before we can deploy is we need to handle the URL query parameters. So that's in the list jobs endpoint. We have parameters that allow us to paginate the results. So if we have a large number of job listings, we want to be able to decide how many we get per response, and we want to be able to sort them out. But also we want to be able to filter by contract type and by the date when they were posted. So if something is too old, maybe we don't want to bother with it. We only want to see listings recently, more recent than a week or so. So we're not gonna bother too much with this because we don't have a database, but we are just gonna make sure we understand how we capture those parameters and how we manipulate them in the function body. And the way we do it is by putting them in the function signature. So what we do here is we say contract type is a string, and then we say date since posted is a string, and page is an integer. Now, contract these are filters and these are pagination parameters. The filters are optional, so they can be set to none. So actually, we're going to say, and in this case, they can actually be none. It's not that they will come as none. So we're going to put it like that. And then page is optional, but it has a default value, which is 1. So by default, we're getting page number 1. Per page is going to have a default value of 10. So per page is another integer, and it's equal to 10. And actually, we could say the specification is a little bit more specific here. It says it has to be bigger than 1 and lower than 100. So let's say this is constrained integer. That's it's a specific type in Pydantic. What it's going to do is to make sure that the value is actually an integer, not something that can be casted into an integer. Although in this case, it doesn't really matter because your query parameters are going to come as strings anyways, but it matters in a payload because we're handling JSON in that case. So what we can do here is going to be equal to 10, and we can say minimum. I need to check the documentation actually, so let's check it out. So we say Pydantic this, and then on int, and then we can pass these parameters. So we want to say it is greater or equal than 1. So we're going to say greater or equal than 1. And we want to say is less than or equal than 100. Like that. And the default value is 10. So, right, okay. So that's how we would define this parameter. That's if we want to have those additional validation rules in the parameter. So, and now let's go back here to FastAPI. Let me put it here because otherwise when the menu comes down, I can't click on it. And also the specification is here. So we have that, and then we have sort by, which is actually an enumeration. We can sort by date posted or by rate. So we're gonna create an enumeration here in the schemas file, and we're gonna say sort by filter. Let's call it like that because it's gonna be for the filtering in this case. All like that. In this case, it's just an enumeration, so we don't need to inherit from a Pydantic in this case. And what we're gonna say is date posted and rate. So date actually following the shape. So posted, which is date time, and the rate is an integer. So let's call it actually like this: sort by filter enum. And this is the value of that parameter here, the type. So is it? All right, and actually it has a default value also, which is sort by date posted. So let's use the enum actually, sort by filter date posted value. Actually, I think it's gonna come as an enumeration like this from Pydantic, so we put it just like that. So we declare it like this. The URL doesn't have a path parameter, so when FastAPI comes to this, it's not gonna try to match this to the path parameter because there is no parameter here. Unlike in these endpoints where we have parameter between the curly braces, these parameters are not set. The type isn't set to a Pydantic model, so FastAPI is not going to try to understand them as payloads. So what is left is query parameters, and that's what FastAPI is going to look for in the URL. So it's going to look for those parameters with these exact names, exactly as the variable that we have here, and it's going to validate them against these values. If those aren't present, then we have default values here. So this one is actually none, and this one is none also. So we don't have a database, so because with a database it's a lot easier. We just pass these parameters to the database, and the database does pagination, filtering and everything. So what we're going to do here is just use some of these parameters to do a little bit of filtering in the list. And next week we can use them more properly against the database. So let's say, first of all, let's create a copy of the list. So we say, let's say result set, let's say query set. That's how we would call it. And we say it's a copy, it's a job for job in jobs. And then we say if contract type, and actually we want, maybe we want to say if job active is, if job is active, if the, because otherwise visibility is supposed to be hidden. So if contract type, we're going to say query set equals, we're going to do another filtering here, job for job in query set. If job contract type equals contract type. Now we need to check, we're going to have to check if the contract type is the same type in both cases and enumerate whether it's the enumeration or the actual string. And then this, we're going to return the query set. And then we want to say if the date since posted is set, we're going to say query set equals job for job in query set if job date since posted, no, sorry, this is listed, date listed is equal or bigger than date since posted. And then we are going to paginate the result. So we say if, how we say, if the length of the query set is bigger than the per page parameter, then we say query set equals, and now we have to think a little bit here. So I already did this before. This is implemented in the repo here. So let's copy it because it's not part of the API implementation really. Right, let's just copy this. So we replace this. Jobs list, let's say query set. We import this and sort. This is sort by filter enum. Okay. The sorting is always set. It's set by default to date posted. So it's going to sort by date listed or by rates, depending on the value of that parameter. And now that it's sorted, first we need to do sorting, and then we can slice the result set. So and it's going to calculate if the value, if it is the first set of the list or if it is another page number 2 or something. What we're going to say, because indexing in list is 0, based on 0, but the pagination is from 1. So we're going to say if it is page number 1, we're going to count from index number 0. Otherwise, we're going to count from 0 plus the whatever we have set in per page. We return that, and actually we're going to change the payload because we want to tell the user also how many pages we have left. So we are going to go to schemas, and in list we're going to say also pages is an integer. So that's not in the API documentation, and I need to update it. And the process we would follow, actually, if we are doing things properly, is we would update the API documentation first, and then we change the code so that we can always validate against the documentation. So that's how we would do some filtering. The server is reloaded. Let's create some jobs, and let's see if we can filter maybe by contract type, for example, and see if it's working. Before we do that, any questions about this part? Okay, we have 20 minutes left. We're going to test this, and then we're going to do deployments. I think we have good time to do that. So let's go to FastAPI documentation here. Let's reload it, unless it's not running. Maybe, oh, something here. Date posted. So this is a problem in line. Oh, actually, yeah, that's not how you define enumeration. So it's with an equal sign, not with a type. There is date posted and rate. Yeah, so I was confused about between the type and enumeration. Okay, so that should be fine now. We can reload the UI. And let's create a few jobs here. So we're going to say Python, everything is a Python dev. But some of them are going to be contract and some are going to be permanent. So let's create some contract first. That is working fine. Let's do some permanent now. And the value should be fine. It's permanent. Yeah, so let's do some. If we do the list here now, we don't change anything. We just query as it is, something happened. So job active is not active, is visible. So where does it say active? Okay. Oh, actually, okay. So something I forgot to put here in the creation. So we set the active by default is true. Every job we create, then you can cancel if you want, but by default everything is visible, so it's active. So let's create the jobs again in the post endpoint. So we're going to create some permanent again, then some contracts. So, oh, okay. What is it? Contract. I made a typo. Contract. Okay. So that's so we should have now permanent and contracts. So if we do this, oh, another one. What happened? It's not supported between string and date time. So this is a date time actually. Okay, so we change that. We server is reloaded, so we lost the data. Let's create some data again. Contract and permanent. Let's do that. Let's do this again. Another problem. In list in line 60. So I guess I have an ISO format somewhere here. Okay, because the ISO format is going to give us a string representation of the date object. So this is something I changed in the middle of the workshop. We had here these dates represented as ISO format first, and then I changed that so that we can use date objects. But I forgot to change the post endpoint. So we were having some dates as strings and some of them as dates. And obviously that can't compare. So this is post. Let's do the under a few jobs and then contract. We do a few other jobs. Everything went well. So we come here. We do this again. Okay, this time it worked. We have permanent and we have everything permanent, and contract is the first one. So let's filter and let's say we only want contract. So if we do this, we should have a bunch of contracts, but that's not happening. So let's do a breakpoint here. Actually, I think the problem is this. So the contract type is the contract type enum. That's what it should be. Right. Okay. So it shouldn't be a string. It should be the enumeration. Then FastAPI will give us the enumeration value, which we can compare with the enumeration value from the object. So let's create another bunch of jobs to make sure it's working well. So we come here again, and that is contract. Let's do permanent. The jobs are well created. So these, okay, permanent jobs. Now let's try to filter by contract. And it works now. Okay. So that was the problem. It was set to a string. So FastAPI was casting the value to a string as opposed to setting it to the value of the enumeration. And it wouldn't work a comparison between enumeration object and string object. So we can filter. Everything should be a contract here if it is working correctly. If we want permanent, then we filter and everything is permanent here. So that is working fine. We can say maybe we only want two jobs per page, and we have 2 jobs. So that's all working fine. Again, we have 5 pages, so it means we have maybe 10 jobs. And we don't need to worry too much about this because all of these filters would be passed to the database eventually, and the database handles this better than we can do here with this kind of algorithms. So I would say we are ready for deployment. So what we're going to do for deployment, we're going to deploy to Heroku. Again, just the simplest choice we can have at the moment. And from the end of the month, I will be using different platforms, something that can be free. So I already created an app here. It's pyjobs-works. I've logged into with the Heroku CLI. So you would do Heroku login, and then you log in through the UI, and it sets an API token in your computer. And then what we do here, we need to initialize a Git repo. And obviously, if we were working formally in a company or in a proper repo, we would commit in every step. Here, we are just going to add everything in one go. And we say add API implementation. And now we need to set them to push to Heroku. We need to set the remote to the Heroku remote here. So we go to settings, and we search for the Heroku Git URL, which is this one, and we say git remote at Heroku. Oops, what happens? Like this. Okay, and now we can say git push Heroku master, and we're gonna force because it's a repo that I've been using from before. So this is a different history, so I need to force the deployment, and we can follow the build process here also in the UI. So if we go to activity, the build is happening here, and so there's one thing missing. I forgot to put the process file. Otherwise, Heroku doesn't know how to execute the application, but it knows how to handle dependencies. So if you have pip file or toml file or the requirements file, you don't need to do anything special. Heroku knows the differences between these files and it knows how to install dependencies correctly depending on the file you have. Now, this is already released, but we don't have a process, so we need to create the process file now. So we say prop file, and it's a web process, because you can also have you can have a job, a cron job or something else. So this is a web service, it's a web process, and we say web, and we set the command that we need to use to launch the web server. So that is ubicon pyjobs, and then we say web server, not reload, no, we need host, so listening on all IPs, and then port is the port from, it's already set by Heroku, it chooses the port. So I believe that's what we need to do. Again, let's check the code that I already tested here. So if we go here to the process file, that is exactly how it works. All right, so we save the file, we add it, we commit, so we say add proc or process file, and we push again. All right, so that triggers another build, and we can wait for that. There's another question here. So it says pipe push should be ports. Oh, did I? Okay, I'll fix it now. Sorry. Thank you for catching it. Yeah, I guess it's not going to work. So let's open the file again, and let's fix it. All right, thank you for catching the bug. So we commit again, so update, let's say prop file, we push again, we follow the build in the UI, and so we go to activity, we follow the build here, and once it's finished, the server will be available. Now this works also the way it works with, it used to work actually with the hobby project with the free dynos, is the server is sleeping until you hit the server. So the first request takes a little bit of time. It's a little bit similar to the serverless functions in AWS. You need to wake up the function. The second request is faster. So should we deploy it now? Let's see if it is working, or maybe we did something wrong. So let's go ahead and check it out. So, okay, so nothing there. If we go to jobs, we get the job that we hard-coded, but we can go to the documentation and be able to test it here and create some jobs. So we do this. Let's create some Python dev jobs. So we create some jobs here, and if we do the list, we may get it or not. The thing that happens in Heroku scales automatically for you, so you don't need to worry about scaling. And if you have too many requests, it's going to launch another kind of instance or pod, and it's going to load balance the requests between these different instances. Now, because they are different instances, and because we have an in-memory list, each of them has its own memory, and you may be creating different jobs with different instances. So the better way to test it, obviously, is when we have a database, then all the requests go to the same database. But you may see some funny results here because everything is in memories, and you will have different pods. Also, the pods go sleeping, so when they come back, memory is recycled, Even the file system is ephemeral in Heroku, so you can't persist anything on the file system or memory. You would have to use a database. But just as a simple illustration of how we would build an API, we don't bother with the database. That's going to happen next week. And hopefully this was a good session of how you work with FastAPI and how you would do a deployment. So we learned how to, first of all, how to understand the requirements of an API specification. We learned how to build the API progressively, starting with the API roots and then adding hard-coded data and then validation models. We learned how to work with Pydantic, how to add URL path parameters to the endpoints and also URL query parameters. And the one thing actually I forgot to put how we handle the special none case in the payload. So remember, in the schemas in get job, state is optional. So let me quickly, we have 4 minutes. Maybe we stay just a little bit longer and I'll show you how we do that. So in get job here, or in get job, which is the one that has the get job has the location model, which has the optional state parameter. So what we do is we override Pydantic's dictionary method to give me the whole function signature here. This one should have also the return value, which is I believe I have it here maybe. So API schemas. Yeah, it should return this. Okay, so a little bit of explanation here. What happens behind the scenes? So when you return something from an API route in FastAPI, you can return either some data, some string, or something that can be serialized directly. So usually you're going to be returning a dictionary in this case because we have a JSON API. Or you can return a Pydantic object. If it is a Pydantic object, the first thing that FastAPI is going to do is call the dictionary method to obtain the expected representation of the object as a dictionary. Then it's going to validate this again against Pydantic, and then it's going to call the dictionary method again. If you return a dictionary directly, like we are doing here, then it's just going to pass the dictionary directly to Pydantic, then call the dictionary method, and then serialize that. So what we can do to fix the payload is we can just override this dictionary method so that when FastAPI calls it, it gets the right payload out of it. What we do is in the keyword arguments and set a variable here, which is called exclude none. Now, actually, FastAPI has an option for that. In the roots, you can say something like exclude and set exclude none. And maybe that's fixed now, but the testing I did recently a few months ago wasn't yet working. Worth checking if it's working now, but last time I tested, it wasn't excluding the non-properties. So while that is fixed, or if it doesn't work, we need to do it this way. Exclude none is true. And then we return by calling the dictionary method from the superclass, and we pass the arguments and the keyword arguments. We pass those because that's what is coming from FastAPI. So we do that. These keyword arguments is additional arguments that tell Pydantic how to produce the dictionary. FastAPI is putting its own arguments. We're going to put our own also, exclude none. And then we call from the superclass, the dictionary method, passing these arguments. So that's what we do here. And if we go back to the API that we are running locally here, it's not running because we were deploying. So we run Ubicon again. And we come back to the list endpoint, for example, and we're going to get just the hard-coded payload, but the state has disappeared because it isn't set. So we can use this method to reformat our payloads and make sure they're always in the right shape according to the specification. So anything that is not directly translatable between Pydantic and JSON schema, we can handle that in these methods. All right, so that's I think that's where we finished. I think we did it quite well. Within 2 hours, we built this job API portal. It's very simple, only has the API layer. Next week, we will continue with the database models, and the following week, we will have the authorization as well, so that if you are a candidate, you make an application, for example, you can access only your applications and so on. That is everything really. So thank you so much for attending. I hope it was useful, and I hope to see you in another workshop. Thank you.